So, hi children. So, this is the last topic, that is a miscellaneous question. Now, this is an easy question that I am not explaining. Hmm. Okay. In each of the following, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. X is an element of A is an element of B. Then X is an element of B? No. Because let children, A is 1. B is, this element will come here. Okay. So 1, 2, 3. Then X is an element, how we will say? Here, this one is this brace that the this full thing is the element. So we can't say one is an element of B. X A is a subset of B. B is an element of C. Then A is an element of C. A is a subset of B. Okay. So A is 1 and B is 1, 2, 3. So you can say this 1 is a subset. A is a subset of B. Okay. Because 1 is contained in B. B is an element of C. So C you can take as like this. Element only, na, then how A will be an element of C? So that is also false. Okay. So third one is easy. Then fourth one, A is not a subset of B. B is not a subset of C. So that A is not a subset of C. Is it true, children? No, it is false. Because A is a subset of C. Okay, look, A is 1. B is 2, 3, 4. C you can take as 1, 5, 6, 7. Okay, so it is false. Now, let A, B and C be the sets such that A union B is equal to A union C and A intersection B equal to A intersection C. Show that B equal to C. So, you have the given condition, so you have to use that. So, I will start with the B. Let X is an element of B. Okay, X is an element of B, it is an element of A union B. A union B is equal to A union C. So, X is an element of A union C. That means X is an element of A or X is an element of C. So X is an element of A and here already we have X is an element of B. That means X is an element of A intersection and the A intersection B. A intersection B is equal to A intersection C. So X is an element of A and X is an element of C. So what we can say from this? B is a subset of C. B is a subset of C. Now next one. X is an element of C. That means X is an element of A union C. A union C is equal to A union B. So X is an element of A or X is an element of C. First you will take X is an element of A. That means X is an element of A and X is an element of C. So that is A intersection C. A intersection C is equal to A intersection B. So X is an element of A and X is an element of B. So what we can say that C is a subset of B. That means B is a subset of C, C is a subset of B. So what we will say? B equal to C. Now, here show that if A is a subset of B, then C minus B is a subset of C minus A. A is a subset of B means X is an element of C. We will start with X is an element of C minus B. That is, X is an element of C and X is not an element of B. Correct? Then, A is a subset of B is given. That means X is not an element of A because X is not an element of B. So, if A is a subset of B, means X is not an element of A. Now, X is an element of C and X is not an element of A. Then means here I start with X is an element of C. Here answer is X is not an element of A. That means X is an element of C minus A. So from 1 and 2 what you can say? C minus B is subset of C minus A. Now, show that for any set, A is A intersection. These things you have to by heart, okay? A intersection B union A minus B. So, A intersection B union A minus B. A minus B, how I can write? A intersection B complement. A intersection B complement. So, A intersection B union A. See, this is a distributive property, na? Means we are expanding something, you will get this one. So, how it will come? A intersection B union B complement. That expansion is this one. Now, B union B complement is what? Universal set. So, A intersection universal set is A. Now, A union B minus A. That is, B minus A is what? B intersection A complement. Then A union. Here we will apply the distributive property. So, A union B intersection A union A complement. This is universal set. Na? Then A union B intersection universal set. That is A union B only. Okay. Now, using, this is very important, using property of set show that A union A intersection B is A. A union, first we will apply the distributive property. What is A union A? It is A only. A intersection A union B. Here common is A, na? So the answer is A. Then A intersection A union B, you can write it as A intersection A union A intersection B. What is A intersection A? A. A union A intersection B. Here A intersection B and A union. That means what? The answer will be this. This is a figure. Then you will understand this. A intersection B, okay, union A. So it is A only. Now, show that A intersection B equal to A intersection C need not imply B equal to C. So we will explain with an example. A is 0, 1. B is 0, 2, 3. Here what is A intersection B? 0. Here A is 0, 1. C is 0, 5, 6. Here also A intersection C is what? 0. But that doesn't mean both B and C set are equal. Now, let A and B be set. If A intersection X is equal to B intersection X is equal to 5, A union X is equal to B union X for some set X, so show that A equal to B. So, A is A intersection A union X. That is, A is A intersection A union X. This is given as the hint. But in the exam, they won't give you the hint, okay? So, A intersection A union X. That means we will combine these two here. A intersection A union X, how I can write A intersection? First, you have to do A union X is given as B union X. Then A intersection B union A intersection C. A intersection B, what is A intersection C? It is given. It is 5. So, A intersection B union 5 will be A intersection B. Here I will take B is B intersection B union X. We have the property that, okay. So, B intersection B union X, I can write it as A union X, then distributive property, then B intersection X is 5. So, B intersection A equal to A intersection B. So, A is equal to B. Okay, children. So, I hope this is clear. Okay. So, if any doubt in the set chapter, please ask the doubts. Okay. So, please go through the chapter. Okay, children. Thank you.